Our I can statement for today is E2. I can solve one-step addition equations. All right, so remember that we learned that an equation says that two expressions are equivalent or equal or have the same value. So we're going to first demonstrate this graphically or visually by looking at the two sides of the scale. Now remember, the scale starts out as balanced and equal, and we want to make sure that whatever we do to one side, we do to the other side so our scale stays balanced. So the first thing that I did is I went ahead and I modeled the equation that we see. The blue pawns that you see are going to represent x's, and the blocks are going to represent specific number values. So we have the x and 3 on one side, and we have 10 on the other side. Just as a quick tip, if you want to draw the blue pawns, a simplified version of this would be a circle and then a triangle below, and then you can fill those in. So that's a simplified version of that guy. And that's what we're going to use to represent x. So go ahead and draw in your pawn, your 3 on the left side, and your 10 on the right side. Green we're going to use to represent positive, and you could also indicate this by putting a plus in front of your box on your paper. Same with this guy. Okay, so since you don't have to use two different colors, you could just do plus and minus to keep track of positives and negatives. Now, our goal is to figure out how much x represents, what it is equivalent to. And when we work with the scale, we've got to make sure that we do the same thing to both sides. Now, if we want to get x all by itself, we want to do something to get rid of that 3. So that's going to be our first step. So what I've shown here is I'm putting minus 3 or negative 3 on both sides, okay? So if I have 3 and then I subtract 3, that's like canceling things out to add up to 0, okay? So it's like these two are completely canceled out, okay? Because 3 minus 3 adds up to 0. So far so good. I've got x all by itself on the one side, but I've also got to figure out what I've got going on the other side. Now, 10 minus 3 adds up to make 7. So we're going to show that on the next slide. Now we're going to show this abstractly or algebraically, meaning we're going to use our numbers and our letters as symbols. So the first thing I've got to do is I've got to do the opposite of this plus 3. So notice that I have a positive or plus 3. So I'm going to subtract 3 from both sides. Okay? Positive 3 and negative 3 cancel out because they make 0. Okay? So I could rewrite this as x plus 0, or I could just write it as x. Okay? On the other side, 10 minus 3 equals 7. So I can say x equals 7. Now, what would you say if I told you that there was a way to know for every single problem, let's say on homework or quizzes or tests, there's a way to know immediately if you got it right or wrong? Well, here's our method. We're going to check our solution by rewriting our original equation, but instead of writing x, we're going to write our value instead. We're going to write 7. So I'm going to write 7 plus 3 equals 10. Then I'm going to total up both sides. 7 plus 3 is 10. 10 is 10. So what I notice is that both sides of the scale are balanced and equal. So that lets me know that my solution is correct. Well, let's try another one. So I've already loaded up my scale. I have x and I have -5. Now remember, on your paper, you could represent this by doing the negative symbol in front, okay? And then on the other side, I also have -8. Now, I want to cancel out the -5. Notice that I'm starting on the same side as x, and I want to get rid of that -5. Well, the opposite of -5 is +5. So, I'm going to add +5 to both sides. Remember that a positive and a negative cancel out to make 0. So those two things add up to make 0. And then -8 and +5 is going to add up to make -3. So what I have shown using the scale is that x has to equal -3. Now let's show this algebraically or abstractly. So I'm going to draw a line down the center, and remember, we do that to keep the two sides of our scale separate. And we want to make sure that we show clear evidence. Okay, so we're going to add 5 to this side and add 5 to this side. Now, positive and -5 add up to make 0, right? So I have x plus 0 or just x. -8 plus 5 is -3. So that's my final answer. Now, let's do the check. So remember, everywhere I see x in my original equation, I'm going to put a -3 in instead. Okay? So I've got -3 minus 5 equals -8. Okay? Now, -3 minus 5 is -8, so I can see that both sides are the same number. Now, I'm just going to throw a curveball here for you. Okay? Let's say that when we did -8 plus 5, we just weren't thinking and we thought that the answer would be +3. So let's see how this would affect our check. So we'd have 3 minus 5 equals -8. And 3 minus 5 is -2, which is not equal to -8. So this is an example of how we would know that we have the wrong answer. Okay? So anytime you're doing the check and the two sides aren't equal, that tells you that we got the wrong answer. So that's how the check's going to work. So let's summarize what we've seen so far. So if we have a problem with addition, okay, what we notice is that the sign in front of the number that's on the same side as x is going to be plus or positive. Okay, so if we have a plus sign in front of the number, so if there is a positive number, then we're going to subtract or add a negative version. And that's how we're going to get x alone. Now, let's look at the opposite. If we have a subtraction equation, that means that the sign in front of the number on the same side as x is negative. So, if we have a negative number, then we want to add, which is the same as adding a positive. Okay, so if you want to see where those two rules came from, you can look at those two previous examples. Now, let's try some examples like you might see on your homework. Okay, and I want to point out that everything that I'm doing is required to be shown as evidence. Okay, so I'm going to draw a line down the center. Now, I notice that I've got a negative or a subtract sign in front of that 1/3. So I want to do the opposite. So I'm going to add 1/3 to both sides. Okay, so what I just did in blue, that is required for full points on the quiz. All right, now positive and negative 1/3 add up to 0. They cancel out. So I'm going to write K equals. Now I can either use mental math or I can type into my calculator 5/6 plus 1/3. So note, you can do it in your head, you can write notes off to the side doing the calculations, but you want to write down what you get as your final answer for 5/6 plus 1/3, and you get 1 1/6. Okay? If you did this by hand, that's equivalent to 7/6, but you do want to simplify. Okay? All right, now we need to do the check. So we're going to write 1 1/6 minus 1/3, and I want to see, does this equal 5/6? Well, I already know what the right-hand side equals. I know that that equals 5/6. So let's type into our calculator. 1 ABC1 ABC6 minus 1 ABC3, enter. And I get 5/6. So that lets me know that this is my correct final answer. Okay, so I just want to point out on the quiz, what number do you put in the answer column? You're not going to put 5/6. You're going to put 1 1/6 because that's our solution. Okay, I want you to try this one on your own. So you can go ahead and draw the line down the center to keep your work nice and neat. I want you to find the correct answer, and I want you to check it to make sure it's correct. Start up the video when you're ready to check your answer. All right, let's go over it together. So I see that I have a positive 1.06 on the same side as m, so I am going to subtract 1.06 from both sides. Okay, positive and negative values of the same number always add up to 0. So this becomes 0. So I have m on one side all by itself. Then I can type into my calculator 5 minus 1.06. A common mistake that I might see on the quiz is we're just not thinking and we might add instead of adding negatives. So you might think, oh, the correct answer is 6.06, and it's not. Remember, when we add negatives, we're getting a smaller number. So my answer here is 3.94. Now, I'm going to rewrite my original equation, but instead of writing m, I'm going to write its equivalent value, 3.94. I'm going to add 1.06 to that, and I want to see, does that equal 5? I know that the right-hand side is 5, so let's type into our calculator. 3.94 plus 1.06, enter. And indeed, I get 5. So that lets me know that m does equal 3.94. All right, try this one on your own and start the video up when you're ready to check your answer. Now this one might have been a little bit tricky. The r is on this side of the equation, but we're still going to do the same steps. I want to get rid of whatever's on the same side as r. In this case, it's the positive 1/8. So I'm going to subtract 1/8 from both sides. So these add up to 0, so I have r all alone on this side. And then I can type into my calculator 3 ABC3 ABC4 minus 1 ABC8, and I get 3 5/8. Let's check it. Does 3 3/4 equal 3 5/8 plus 1/8? I can use the calculator to help me see what the second side equals, or I could use mental math. 5 plus 1 would be 6/8, and 6/8 simplifies to 3/4. But I always want you to double check in the calculator to make sure that you're doing the addition correctly. Okay, but once we type it in the calculator, we see that both sides do equal 3 3/4. So my final answer is 3 5/8. So that's it for the examples for today. Remember that you can watch the video as many times as you need to for a refresher, and make sure that you have all the evidence that I've shown on my paper written down on your notes. You will be docked points if you don't show enough evidence. Remember that you need to show evidence that whatever you do to one side, you do to the other side, and that way you can prove that you kept both sides of your scale balanced. Thanks for watching.